So here we're going to look at calculating taxes. You know, like when you buy something in a store, there's a certain percentage, that's a tax, right? Well, that is a percentage, so let's consider that. So let's suppose the sales tax in some town, right, is 12.1%. Well, then we can ask, okay, well, how much tax are we going to pay if we buy or, if we purchase something, right? Well, tax would be part of the whole. Tax is part, whole would be the entire purchase. So let me say it again. Tax is part, whole would be the entire purchase. Okay? That's what I'm saying here. So basically, if you want to get the tax on something, right, you can use this equation. So for instance, the $110, right? You would have, so if you want to say, okay, how much tax would be if you buy or spend, if you purchase something that's $110? Well, again, percent as a decimal, 0.121, that would be our tax. And we're dividing by $110, as you can see. So how do we get tax? Well, again, we're going to cross multiply. Or you could think of it as multiplying both sides by 110. Same idea. And so we get this, as you can see. All right. So from here, we get our tax, which turns out to be $13.31, after you rounded the two decimal places. So that's how much tax we're spending. Okay, that's good. Okay, what about part B, the $25? Well, it's the same idea. The only difference is that the purchase is a different amount. But it's the same idea. I mean, basically we're asking is, what is 12.1% of whatever the purchase is? And that's what I'm doing here. That's what we're doing here. So we get this. Okay. So here we get $3.03. So that's tax. That's a percentage. Okay. What else is a percentage? Well, a tip, right? Like when you buy something at a restaurant, when you go out to eat, and then you want to pay a certain tip. You want to leave the waiter or waitress a tip, right? Which is a certain percentage. Even when you go somewhere like get a haircut, you want to leave a tip, right? Which is a percentage. So percentages do come up. Okay, but before we get the tips, actually, let's consider this. So this is kind of like what I was saying before, how percentages can be used, in the news and stuff. You might see like, okay, well, it turns out 40% of all the people in some town said that they're going to vote for this person. But what does that really mean, though? What is that telling us? Well, let's suppose there are 1,500 people in the town. We can determine how many people are going to vote for this person, John Doe, right? Namely, you can kind of see it from, you can kind of see it from the wording here, but the whole in this case would be the entire town, whole. Part would be the people voting for that candidate, right? That's what the percentage is telling us. 40% of the people in the town. Of the people, the whole would be the entire town. Part would be the people voting for John Doe. Okay, well, how many people are going to vote for him? We can calculate that. That's what I'm doing here. I know the fraction's written a little strange here. Namely, we have part over 1,500 is how it's written. It's not like one directly over the other is what I'm saying, but it's still a fraction. But from here, we have 0.40 is part over whole, which in this case, the whole, again, is the entire town, 1,500. So part which is what we're looking for, would be the product. That's what I'm doing here. So we get about 600 people. So they tell us about 600 people are gonna vote for John Doe. Okay, that question wasn't so bad. But now let's make it really interesting. What if I told you instead that the 1,500 people is the 40%? So in this case, we're telling you that the 40% of the town is the 1,500 people. How many people are there in town? Well, in this case, we're given the part, right? But we want to figure out what the whole is. Part is the number of people in town. Whole is the entire town. That's what we want to figure out. I mean, it's not that bad. We could figure it out. You know, it takes a little more algebra than the previous question. That's okay. So we have this, as you can see. So how do we get whole? Well, here's how we do that. We can cross multiply, right? Basically, this is what I mean by multiply. We're going to multiply both sides by whole, right? By doing so, these cancel. We're left with this. Then from here, right, we want to get whole. Whole is our x, basically. And to get that, we divide, right? 0.40, we can divide by that. Then we have whole, which is equal to this. And when you carry out this division, you get this number. Think after rounding to no decimal places. Okay, so that's what we end up with, as you can see. So the number of people in town is about 3,750 people. That's how many people there are in town, approximately. Okay, that's good. So we have that one. Are there any questions about this? Okay, let's keep going then. Oh yeah, so then that's how many people there are in town. All right, now, when you have changing quantities, you could have these two, you could run into these two notions of absolute change and relative change. Absolute change and relative change. Basically here, the absolute change, by definition, that's just the ending quantity minus the starting quantity. You know, so if something changes value, like the price of something or how much something's worth, you can consider the absolute change. And then from there, you can form what's called the relative change. Basically, to get that, you just divide by the starting quantity, which is over here. And then you can convert this to a percent if you want. Namely, what you would get then, you just multiply by 100 and you would get the percent change. So the percent change is the relative change expressed as a decimal. Excuse me, expressed as a percentage. And again, you just multiply by 100. That's all you do. All right. I'm not sure if this will come up, okay, in the course. I've seen it come up before in other courses, but sometimes what can happen is you might end up subtracting one percentage from another. Or, you know, in general, you can add percentages. The unit for that sum or difference is percentage points. That's just what a percentage point is. It's the unit used for subtracting or adding percentages. Again, that's just what it is by definition. So that's absolute and relative change. Let's actually do an example. Oh boy. There we go. So this is what me and running. I did this example. For one thing, I run a lot. Also, because I read in Runner's World that they say you should increase the total number of miles you run in a week by 10%, I think. So I figured, okay, let's consider this example. This is where I got it from. So one week I ran, let's say 25 miles total. But let's say the next week I pushed myself and I ran 28 miles total. What I want to do is calculate the percent increase in the number of miles. Excuse me. We want to calculate the percent increase in the number of miles. But again, notice here in the problem, this is our starting quantity, right? 25, we're starting here. Our ending quantity is the 28 miles. Starting, ending. So the absolute change would be this, as you can see. But I want percent change, percent increase, right? Not just absolute change. So we have to get relative change, then we multiply by 100. Then we have to multiply by 100. So the percent change, again, you divide by the starting quantity, as you can see, right? So we have 3 over 25, which is 0.12. As a percent, we get 12%. So the percent increase is 12%. So it's a percent increase is 12%. So that's this example. Okay, let me just, I gotta stop the recording because, if